welcome back to Neuropsychology. So in the last couple videos, we talked about the three classes of drugs based on their most pronounced effects. So we talked about sedative hypnotics and anti-anxiety agents. We talked about antipsychotics and antidepressants and mood stabilizers. And in this video, we are going to talk about opioids and psychotropics. So let's start off with the opioids. So an opioid is any compound that binds to a group of brain receptors that are also very sensitive to morphine. So there are two natural sources of opioids. One of them is opium, which is an extract from the seeds of an opium poppy, as you can see in the right top picture. And opium has been used for thousands of years to produce euphoria, analgesia, and sleep. The second natural source of opioids is in the brain. So the peptides in the body that have opioid-like effects are called endorphins. So these are also actually called endogenous morphines. So morphine most closely mimics a subtype of endorphins in the brain. In addition to natural opioids, many synthetic opioids such as heroin work similarly as morphine. So heroin is technically synthesized from morphine, but it's more fat soluble and it penetrates through the blood barrier way more quickly. So this allows it to produce a very rapid but very short-acting pain relief. Okay, so by acting at these opioid receptors, opiates such as morphine or heroin, they're extremely potent painkillers, but they're also very addictive. Synthetic opioids, such as heroin, they affect one of three receptors called mu receptors. And as I just said, heroin is synthesized from morphine, but it's more fat soluble. So three well-known synthetic opioids are heroin, methadone, and oxycodone or oxy. And all opioids are potently addictive, and abusive prescription of opioids is actually very common. Okay, after a prolonged period of medical opioid use, people can develop a need for increasing amount of opioid medication. So with tolerance, in only a few weeks, the effective dose may rise tenfold, and many of the desired effects will eventually go away. So morphine quickly results into tolerance, so the possibility of an overdose is crazy high. There are several drugs out there that can act as antagonists at opioid receptors. So examples of these are nalorphine and naloxone. So these drugs are what we call competitive inhibitors. So what they do is they compete with opioids for the receptors on the neurons. So they technically steal the spots where the opioid wants to bind and sit, and they block it so the opioid cannot bind there anymore. So they can enter the brain very quickly and they can block the actions of morphine. So many people that are addicted to opioids, they carry these competitive inhibitors around as a treatment of overdosing. So they're actually very long active. So often they're also used to treat opioid addictions after a person has recovered from their withdrawal symptoms. Okay, so let's talk about the last group, psychotropics. So psychotropic drugs are stimulants, and they mainly affect mental activity, motor activity and arousal, and perception and mood. So there are three groups. We have the behavioral stimulants, we have psychedelic and hallucinogenic drugs, and we have the general stimulants. So behavioral stimulants affect motor activity and mood. Psychedelic and hallucinogenic stimulants affect perception, and they can produce hallucinations. And the general stimulants mainly just affect your moods. An example of that is coffee. Okay, so behavioral stimulants increase motor behavior as well as they elevate a person's mood or alertness. So they're kind of used to boost alertness, but they are also very addictive. So cocaine is a powder that is extracted from the Peruvian coca shrub. And refined cocaine powder, people either like sniff it or they inject it. And there's another form, which is crack. And crack is a chemically changed cocaine that vaporizes very quickly at low temperatures. And then the vapors are inhaled. So Sigmund Freud popularized cocaine in the late 1800s as an antidepressant. And it was once widely used ingredient in soft drinks as well, and even in wine mixtures, promoted as pepping tonics. So it is the origin of the name Coca-Cola, because this soft drink actually contained cocaine once upon a time. So cocaine was also promoted as a local anesthetic, and many derivatives nowadays, such as Novocaine, are still used today. So these local anesthetics reduce cells' permeability to sodium ions, and therefore they reduce nerve conduction. Okay, so moving on to the next drug is amphetamine. And amphetamine is a synthetic compound that was discovered in attempts to create the neurotransmitter epinephrine in our body. And epinephrine also acts as a hormone mobilizing the body's for fight or flight in times of stress, as we talk about later in the hormone section. So amphetamine promotes the release of dopamine into the cleft. And both amphetamine and cocaine are dopamine agonists, and they act by blocking the dopamine reuptake. So whenever the dopamine did its job, it's going to go back into the cell. However, amphetamines and cocaine will block this reuptake. So by doing this, they will interfere with the reuptake mechanism, and there will be more dopamine in the cleft. And both mechanisms will increase the amount of dopamine available in synapses to stimulate dopamine receptors. Amphetamine-based drugs are widely prescribed to treat attention deficit hyperactivity disorder. And often people kind of abuse it to help with study aids too. So there's an amphetamine derivative, which is called methamphetamine, or also known as meth or speed, and it's widely used in the US. So the reason it's widely used is because it's pretty easy to manufacture, and a lot of people are illegally making this. However, it is very dangerous. So over time, meth destroys a lot of dopamine receptors in your brain. And here you can see a picture of before and after chronic meth use. Okay, so far we talked about behavioral stimulants as a subgroup of psychotropics. Now we're going to go over the psychedelics and hallucinogens that fall under psychotropics as well. So psychedelic drugs alter sensory perception and cognitive processes, and they can produce hallucinations. So we categorize the major groups of psychedelics by their action on a specific neurotransmitter. So we can divide it in 5 groups. We have the acetylcholine psychedelics, the anandamine psychedelics, glutamate psychedelics, norepinephrine psychedelics, and the serotonin psychedelics. So let's go over those one at a time. So acetylcholine psychedelics are drugs that either block acetylcholine transmission, such as atropine, or they can do the opposite and they can facilitate it, such as nicotine. And then we have the anandamine psychedelics. They have a role in forgetting or impairing memory, according to certain researches. So anandamine is a Sanskrit word for joy or bliss. And anandamide prevents the brain's memory system from being overwhelmed by all the information to which we are exposed every day. So you will only remember certain things and you will not make memories of other things. So THC, or tetrahydrocannabinol, is the active ingredient in one of the anandamide psychedelics, and this one is marijuana. So it is obtained from the hemp plants Cannabis sativa, and THC acts on the endogenous THC receptors for anandamide in your brain. So THC use may have negative effects on your memory, but it also has positive effects on mental overload. THC is used in many therapeutic ways for clinical conditions. So it relieves nausea and vomiting in patients that are undergoing chemotherapy. It can stimulate appetite in AIDS patients. And THC has also been found helpful for treating chronic pain through mechanisms that appear to be different from those of opioids. So it's way safer. It has also been shown to be helpful in treating glaucoma, which is increased eye pressure, and also in spastic disorders such as multiple sclerosis and disorders associated with spinal cord injuries. Some studies should suggest that THC has neuroprotective properties. It can aid brain healing after traumatic brain injury and slow the progression of diseases associated with brain degeneration, such as Alzheimer's disease and Huntington's disease. And reports also test that some ingredients in marijuana reduce epileptic attacks. Okay, let's move on to the glutamate psychedelics. So PCP, or phencyclidine, and ketamine can produce hallucinations and out-of-body experiences. Both these drugs were formerly used as anesthetics, and how they work is they block glutamate and MDA receptors that are really important for learning and memory. So primary psychoactive effect of PCP will last for a few hours, but it takes about 8 days for PCP to get out of your body. Okay, so moving on to the norepinephrine psychedelics. A form of norepinephrine psychedelics is mescaline. And mescaline is obtained from the peyote cactus, and it's actually legal in the US for use by Native Americans for certain religious practices. Mescaline produces pronounced psychic alterations, and it also includes things like sense of spatial boundlessness and also visual hallucinations. So the effect of a single dose can last up to 10 hours, which is really long. And the last group of the psychedelics are serotonin psychedelics. So a synthetic drug, lysergic acid diethylamide, or LSD, is a naturally occurring substance which is obtained from a mushroom. And it stimulates some serotonin receptors and blocks the activity of other serotonergic neurons through serotonin autoreceptors. Then we also have ecstasy, or MDMA, which is also a serotonin psychedelic. MDMA is one of several synthetic amphetamine derivatives that affects the serotonin neurons. Okay, and we also have the general stimulants as a subgroup in the fifth class. So general stimulants are drugs that cause an overall increase in a cell's metabolic activity. So caffeine, for example, is a widely used stimulant. It inhibits an enzyme that ordinarily breaks down the second messenger cyclic adenosine monophosphate, or we also call that cyclic AMP. And the increase in this cyclic AMP will lead to increased glucose production within cells, and that will make more energy available and allows higher rates of cellular activity. So a cup of coffee contains about, let's say, like 100 milligrams of caffeine, and also many soft drinks have just as much in there, such as like a Coca-Cola or something. And excess levels of caffeine can lead to jitters. And if you're a regular caffeine user and you quit cold turkey, you can experience headaches or irritability and also other withdrawal symptoms. Nicotine is also a very common substance of abuse, and it affects about like 26 of North Americans. So a study by Stein et al., they used fMRI to identify the regions of brain activity after smoking. And they found increased activity in the nucleus accumbens and amygdala, and also in the cingulate orbital frontal region. So all these regions are targets of dopamine projections. And they're actually also doing a bunch of studies at FIU where they study cigarette smoking. Okay, so now we talked about all the groups of drugs. Let's briefly talk about addiction and dependence. So substance abuse is a pattern of drug use in which people rely on a drug chronically and excessively. So it will occupy a central place in their lives. A more advanced state of the abuse is substance dependence, or what we also call addiction. Addicted people are physically dependent on a drug in addition to abusing it. So they have developed a tolerance for the drug, and so an addict requires an increased dose to obtain the same desired effect. And this is because of receptor downregulation, which I'm going to talk about in a couple slides. So drug addicts may experience unpleasant and sometimes very dangerous physical withdrawal symptoms when they suddenly stop taking the abused drug. So these symptoms can include muscle pains or aches, twitches, anxiety attacks, sweating, or nausea. And sometimes it can even result in convulsions and can result in death. Okay, so here is a slide that I wanted to talk about receptor downregulation. So when you're addicted to a drug, your cells will downregulate the receptors in your neurons. So let's go over cocaine, for example. Whenever you are addicted to cocaine and use it a lot, you will have downregulations of your dopamine receptors. So when people use a drug, there will be an increase of dopamine, in this case, in the cleft. And then whenever there's repeatedly so much dopamine in your cleft, your cells are going to be like, whoa, that's way too much. Let me kick it back by taking a bunch of these receptors out. So they take it out, so there's less stimulation. So the body reacts to this by taking away receptors to make it go back to baseline. So this is the downregulation. So the more drugs you use, the more receptors the body will take away. So hence you will need more and more and more of the drug to get the same effect of stimulating these receptors. Okay, and that was the end of this video, and I will see you guys back soon for the next one.